If you've used React to build a web application, chances are you've had significant challenges with state management. For too long, we relied on typical Redux for state management. But because of its complexity and the excessive amount of code it takes to get it working, we eventually turned to other solutions like the React Context API. What if I told you that a new tool named Redux Toolkit exists to make the Redux state management process as simple as possible? It's easy to set up and use while remaining as efficient as the popular Redux library. In this course, you'll learn about creating Redux stores, reducers, actions, slices, and making API requests by building a shopping app. To follow along, you'll need knowledge of JavaScript, functional components in React, and basic state management with React hooks. During this course, we will build a shopping app and release it to learn Redux Toolkit. We'll look at how to use Redux Toolkit to share data between our home and cart components. The actions on the home page, like remove from cart, are the same actions we have on the cart page. So whenever we click the remove item button, the item gets removed from the cart. We return to our home page, click the remove from cart button, and the same thing happens. As you can see, we're able to share data between our home, navbar, and cart components without the need for props. And this is why I like to use Redux Toolkit for state management in my React applications. Redux Toolkit is the official and opinionated toolset for efficient Redux development. It comes out of the box with everything you need for state management in React apps. What's Redux? Redux is an open source JavaScript library for managing and centralizing your application state. You'll often see React developers use Redux as their go-to state management tool. Redux Toolkit is intended to be the standard way to write Redux logic. 3 common concerns about Redux that Redux Toolkit was created to help address are the complications involved in configuring a Redux store, the need to add a lot of packages to get Redux to do anything useful. Redux requires too much boilerplate code. For a long time, we used just Redux for state management, even with all of these issues and complications. This is because Redux is still a great tool. Even though the core library is bare, it's extensible. And when used together with some other tools, it does a great job. The Redux core library is deliberately flexible, but many times this flexibility does more harm than good, as it introduces unnecessary complications to a code base and takes up too much development time. This is where Redux Toolkit comes in. With Redux Toolkit, we have out of the box all of the functionality that Redux would have only when combined with additional libraries. If you want the simplest possible way to handle state management in your React apps with some good default behavior out of the box, or maybe you're writing some similar code in a large application and would like to cut down on how much of that code you have to write by hand, then Redux Toolkit is for you. Redux Toolkit makes it easier to write good Redux application and speeds up development by baking in the Redux recommended best practices, providing good default behaviors, catching mistakes, and allowing you to write simpler code. Regardless of your skill level or experience, you'll find Redux Toolkit a beneficial tool for your React application. For Redux to work, it requires 3 main building parts: actions, reducers, and the store. Let's start by understanding actions. In Redux, actions are objects that are used to send data to the Redux store. They usually have 2 properties: a payload property that contains the data we want to put in our Redux store, and a type property that describes the action. The value of the payload property can be of any data type, while the type property is usually a string. How about reducers? What are they? Reducers use actions to know what to do with our Redux store. If an action tells the reducer to add, remove, or update existing data in our store, the reducer takes the action's payload and does just that. Here's what a simple reducer looks like. Reducers are pure functions that have the current application state and intended action as their first two parameters. In typical Redux, creating actions and reducers are a bit more complex than our examples so far, but you don't have to worry about that. Redux Toolkit has a simple way of helping us write reducers and generate actions. Without the Redux store, our actions and reducers cannot fully function. And in any Redux app, there can only be one store. Since the store is so important, what does it do? For starters, the store is where we keep the application state. So if we want to use Redux for state management, we will need to create a Redux store. The store doesn't just hold the current application state inside of it. It also allows us access to the state. That means we can use a getState method from the store to get our application state. We can also update our application state with the store.update method. And along with that, the store handles the registration and unregistration of listener callbacks. The store is able to function with the help of the actions and reducers. The actions tell the reducers how to interact with the store, and the store allows the reducers to access and modify the application state. To create a store, we'll have to import the configure store method from Redux Toolkit. Then, we create a variable named store. This can be named anything, but we'll go with store because that's easy to understand. As our store's value, we'll call the configure store method, and as an argument to the configure store method, we'll have an object with a reducer property and value. That's about it for creating a Redux store with Redux Toolkit. To access our application state from the store, we can use the store.getState method, and to update our state, we have the store.dispatch method. When we start building our application, we'll see more of the store in action. A Redux app can have as many slices as is needed to represent each part of the application. So you can think of a slice the way you think of parts of a pizza or a loaf of bread. To create a slice, you need to import the createSlice method from Redux Toolkit. Next, you create a variable for your slice and then as its value, call the createSlice method. The createSlice method expects a single object as its argument, which is used to configure the slice. For the object properties, we need to provide values for name, initial state, and reducers. There's also an optional property named extra reducers. The name property tells Redux the name of the slice of our app state. The initial property provides our store with the initial state value of this slice of state. This value can be of any type, including strings, arrays, objects, and boolean. The reducers property is where we write the different reducers for specific actions that we want performed on this slice of our application state. This property expects an object with one or multiple key value pairs representing the name of our reducer functions and the functions themselves. As we progress, you'll see by example how to create slices, write reducers, and generate actions. Let's go to our editor or IDE of choice and set up our project. When you open up the repository and go to the 0201 branch, you'll see our base project template. This project was set up using Create React App, and when you navigate to the public directory, you can see the index.html file right here. Inside the index.html file, we have a link to our Bootstrap CDN because we're using Bootstrap for styling our app so that we can only focus on what's essential in Redux Toolkit. When you open up the SRC directory, you'll see the components folder, a data folder, and the styles folder. The data folder is where we have our application data and where we'll put our Redux store. which is the cart component, and on line 1, we started by importing product list from the data directory. We've also imported the cart.scss file from our styles directory, which contains style files for our app. We're creating the cart components on line 4, which returns our JSX code. On line 9, we are mapping through all the products in the product list array and displaying each on our cart page. Since we'll be getting our cart items from the Redux store, we'll come back later to modify this so that inside our product list, we'll use cart products from the Redux store. When we scroll down, you see that we have a div that says your cart is empty. We'll only show this when there's no item in the cart. We also have the home.jsx file, which contains our product catalog, and inside of our product catalog, we're also importing product list from the product list.json file. Like we did in the cart component, we're mapping through the product list data and displaying each of our products on the home page. On line 18, we have a button which we're going to use to add items to the cart. We'll add an on-click event listener to our button so that when a user clicks it, the particular item that the button belongs to will be added to the cart. We'll use Redux Toolkit to implement this. The navbar.jsx file is where we have the navbar for our application. We'll also use Redux Toolkit on line 13 to display the number of items in our cart instead of the current hard-coded data, so that whenever we update our cart, it'll also change to reflect the new cart data. Now that we've gone through the structure of our project, we can go over to a terminal and run the command npm install to install our packages. Then npm start to start up our application. When we open our app on the browser, it will look similar to the finished project we saw earlier, only that its functionalities don't work yet. There's no store we can add items to, and when we go to the carts, you can see that the products here are all from the product list.json file. And right here, we also have this message that should only appear when the cart is empty. On the navbar, we have the hard-coded data 7 instead of the number of items in our cart. Now, you should have the base knowledge to set up your app and follow along. To set up Redux Toolkit, we will start by going over to our terminal, and inside the application directory, let's run the command npm install at redux.js/toolkit, and we'll specify its version as 1.6.1. We also want to install React Redux, which we'll use to provide the Redux store to our React application. Let's also specify the version as 8.0.1. These are the current versions at the time of recording this course. With Redux Toolkit installed, we can now create a Redux store. We'll go to the data folder inside of the src directory and create a file named store.js. In our store.js file, let's start by importing configure store from Redux Toolkit. Next, we'll create a variable named store, and as its value, we'll call the configure store method, which we imported on line 1, and pass an object as its argument. This object will contain a key named reducer, where we'll create the parent reducer for our application. We'll put the card reducer and any other reducer we create in our application inside this parent reducer. Let's make our store the default exports from the store.js file. Next, we'll provide our created store to our React application so that every other component can access it. Let's open our index.js file and start by importing provider from React Redux. Next, we'll wrap our app component on line 9 inside our Redux provider. Now we can import our created store from the store.js file and provide it to our app using the store prop in our provider component. With our store successfully set up, let's see how to create actions and reducers so that we can add, remove, and update data in it. With Redux Toolkit, You can have as many slices as you want in your React application. Inside the data folder in our src directory, let's create a file named cartslice.js. In our cartslice.js file, we'll start by importing createSlice from Redux Toolkit. Next, we'll declare a variable named cartSlice. And as its value, we'll call the createSlice method, which we imported on line 1. Let's provide an object as its argument. In the object, we'll start by giving our cartSlice a name. We'll call it cart. We'll also give it an initial state. Whatever we supply as the value of initial state will be the starting state of our cartSlice, even without adding any data to it. For the value of our initial state, we'll create an object with the property cartProductIds and set its value to an empty array. To add a product to our cart, we'll take its ID and append it to the cartProductIds array. Next, we'll add the reducer's key, which will contain the actions for our cartSlice. Each action is a function which expects the parameters state and action. We'll access our cart state using the state parameter and the action payload from the action parameter. The payload is the data we pass as an argument to the functions when we call them. Let's create an action for adding items to our cart. We'll name it add to cart. The value of our add to cart function will be an arrow function with parameters state and action. In our add to cart function, we will get cartProductIds from the state parameter and update its value. So this should be state.cartProductIds, and as its value, we have an array. The first element of our array will be the payload from the action parameter. And for the second element, we'll use the JavaScript spread operator to include all the existing cartProductIds in our state. Now this is state.cartProductIds. We'll also create an action for removing items from our cart, and we'll name it remove from cart. We'll do the same thing we did for the add to cart function with parameters state and action. On line 13, we'll create a variable named index of ID. And as its value, let's use the array.indexOf method from state.cartProductIds to get the index of the particular item we want to remove from our state. So we have state.cartProductIds.indexOf ends action.payload. We can now use the array.splice method to remove it from our cartProductIds array. State.cartProductIds.splice. And for our splice arguments, we have index of ID and then 1. Next, we'll create an action for clearing all items in our cart, and we'll call this when a user clicks the checkout button. Let's name our action clear all items. For our functions parameter, we only need state. Let's give state.cartProductIds an empty array as its value. Now, whenever we dispatch the clear all items action, all the product IDs in our cart state will be cleared. Our cartSlice variable now contains our created actions and reducer. We'll use cartSlice.reducer in a store.js file and the actions to add, remove, or clear all items in our cart state. We can now export cartSlice as the default for the cartSlice.js file. Instead of exporting cartSlice as the default, we can also destructure actions as cart actions and reducer as cart reducer from the cart state. So this is going to be actions as cart actions on line 22 and reducer as cart reducer from cartSlice. Now we can go ahead and export cart actions and cart reducer, but for simplicity, we'll leave cartSlice as the default export. Let's go to our store.js file and add our cart reducer to the reducer object. We'll import cartSlice on line 2. Then we'll add a new key named cart to the reducer object and give it the value cartSlice.reducer. If we add more slices to our application, we can also bring their reducers to this reducer object. Next, we'll see how to use our cart slice actions to add and remove items in our cart state. Let's start adding items to the cart. We'll add items by clicking the Add to Cart button. So if we click the Add to Cart button for this Spring Robot item as an example, its product ID will be added to our cart slice. Back to our code base, let's import the cart slice from the data/cartslice.js file. Now on line 2 we have import cart slice from data/cartslice. We're also going to import the useDispatch hook from React Redux, and we'll do that on line 1. We'll use it to dispatch actions to our Redux store. So we'll get the cart action from the cart slice and then use the useDispatch hook to dispatch that action to our Redux store. In our home component, let's create a variable named add to carts, and we'll do that on line 7. And as this value, we have cart slice.actions.add to carts. We can also destructure this by putting add to carts in curly braces, and then we have cart slice.actions. We will also need the remove from cart action, so let's get it from cart slice.actions. Next, we'll declare a variable named dispatch, and as this value, we'll call the useDispatch hook. We can now use this dispatch function to dispatch the add to cart action. We'll go over to line 23 where we have the add to cart button and create an on-click event listener. Inside our event listener, let's call the dispatch function. As its arguments, we'll also call the add to cart action. For our add to cart function, we'll need product.id as its argument. Clicking our add to cart button will trigger its event listener, which will dispatch the add to cart action. Our add to cart action will take the product ID that the button belongs to and add it to our cart slice in the Redux store. Let's create another button for removing items from our cart. We'll duplicate the add to cart button and change its text to remove from cart. In its event listener, instead of dispatching add to cart, we'll dispatch the remove from cart action. Now, when we click the remove from cart button, it will dispatch our remove from cart action. This is how the useDispatch hook and cart slice actions are used to update our Redux store. To render our cart buttons conditionally, we'll need to get our cart data from the Redux store. We only want to show the add to cart button if an item is not in our cart, and if it's already in our cart, we'll display the remove from cart button instead. First, we need to get all the product IDs in our cart state, and we'll do this by using the useSelector hook from React Redux. On line 1, along with the useDispatch hook, let's import the useSelector hook. Next, in the home component, we'll create a new line and a variable named state. As its value, let's call the useSelector hook and pass a function as its argument. We'll provide a parameter to our function and make the parameter our function's return value. This return value will be our Redux store data, so we'll name it state. Now we can access our cart product IDs from state.cart.product_IDs. We're able to access our Redux store with the useSelector hook because we already provided it to our app component using provider from React Redux in the index.js file. Back to our home component. We can also directly destructure cart product IDs from state.cart instead of creating a state variable. So on line 7, we can write cart product IDs, and this should be equal to state.cart. With our cart product IDs available, let's wrap the add to cart button in curly braces and then in parentheses so that we can conditionally display it only when its product ID is not in our list of cart product IDs from the Redux store. We will use the logical NOT operator and the JavaScript array.includes method to display our add to cart button conditionally. Let's do the same thing for our remove from cart button. First, we'll wrap it in curly braces and then in parentheses. And we have cart product IDs dot includes product dot ID and the remove from cart button. Next, let's log cart product IDs on line 11 to see if our cart slice buttons and actions are working correctly. Over to our browser, we open up the console. See that when we click the add to cart button for a product, its ID gets added to our cart state and the button changes to the remove from cart button. When we click the remove from cart button, the product ID also gets removed from our cart state. We are now able to get data from our Redux store with the useSelector hook, and our cart buttons are working correctly. When we add a product to our cart, we'll also need to display it on the cart page so that when a user clicks the cart button, they'll see the new product. Let's open the cart.jsx file inside the components directory. On line 1, we'll start by importing the useSelector and the useDispatch hooks from React Redux. We'll use the useSelector hook to get our cart data and the useDispatch hook to dispatch the remove from cart action so that users can remove cart items from the cart page. Inside our cart component, we'll get the cart product IDs from our cart slice in the Redux store. So let's have cart product IDs, and this is equal to useSelector, and we'll give our useSelector hook a function argument with parameter state, and this should return state.cart. Next, we'll create a variable named cart product data, and for its value, we'll filter the product list.products array and get all the products that have IDs from the cart product IDs array. In a filter function, we're going to return cart product IDs dot includes product.id. Next, instead of mapping through products from our product list.json file, we'll map through the cart products in the cart product data variable. Let's save this and go back to the browser to see what we have. Right in our cart page, see that the items we just added to our cart are displayed. We also have this message that says your cart is empty. We're only going to display this message when there's no data in the cart product ID state. So let's go back to our code base and add a condition for displaying cart data. We'll wrap our cart product div in curly braces and then in parentheses. For the condition, let's only display it if cart product data dot length is greater than 0. We'll also wrap the empty cart div in curly braces and then in parentheses. For condition, let's only display it if cart product data dot length is less than 1. Back to the browser, see that the empty cart div is no longer visible. Next, let's make the remove item buttons work so that we can use them to remove items from our carts. On line 1 of our cart.jsx file, let's create a new line and import cart slice from data/cart slice. We can now destructure cart slice to get the remove from carts and clear all items actions. So we have remove from carts on line 10 and clear all items. And this is equal to cart slice dot actions. We'll also create a variable named dispatch. As its value, let's call the useDispatch hook. Now we can add an on-click event listener to our remove item button. On line 25, we write our on-click attributes and let's call the dispatch function. For our dispatch function's argument, let's call the remove from cart function. We'll pass product.id as its argument. For our checkout button, we'll add an on-click event listener that dispatches the clear all items action. On line 33, let's add the on-click attributes and we'll call the dispatch method. For our dispatch method's arguments, we'll call the clear all items action. Let's go back to our browser and try to remove items from our cart. When we click the remove item button for the Spring Robots item, we see that it's no longer in our cart. We scroll down and click the checkout button, and this removes all items from our cart. We can also see that the your cart is empty message is now displayed. To make the number of cart items display correctly on our navbar, we'll also use our state's cart product IDs in the navbar component. Back to our code base, and inside the navbar.jsx file, let's import useSelector from React Redux. Next, we'll get cart product IDs from our state. On line 6, we have const, and inside our curly brace, we have cart product IDs equal to useSelector, and inside our useSelector hook, we'll create another function with state assets parameter and we'll return state.cart. For our cart number value, we can now use cart product IDs.length. On line 16, we have cart product IDs.length. Back to our browser, you see that the number of items in our cart is now 0. And when we add products to our carts, the value changes. We are now able to display our cart product data, remove items from the cart page, clear all items in our cart, and see the number of items we have on the navbar. To handle asynchronous logic in Redux, you need to set up a middleware with an external package like ReactJS. But Redux Toolkit provides a built-in createAsyncThunk method for handling and processing asynchronous logic like API requests before supplying the result to our app producers. To show you how this works, we'll create a local API using a JSON server from npx and the data in our product list.json file. Let's go over to our terminal and run the command. First, let's create a new slice file in the data folder named product_slice.js. We'll use the product slice file to manage our product list state instead of the previous product list.json file. On line 1, let's import createAsyncThunk from redux.js/toolkit. We'll use the createAsyncThunk method to create an action for fetching all products. Let's create a variable named fetch all products. As its value, we'll call the createAsyncThunk method. The createAsyncThunk method expects 2 arguments, a string for describing the Redux action type and a callback function that should return a promise. The createAsyncThunk method, when called, will also return a promise as its value. Since we want to use our fetch all products action for fetching all products, let's name the action type fetch all products. We might not use this string much in our Redux Toolkit app because we can directly dispatch the fetchAllProducts function with the useDispatch hook. For the createAsyncThunk second argument, we'll create a function. Let's make it asynchronous. We'll give it a parameter named API URL, and we'll be able to supply this API URL parameter when calling the fetchAllProducts function. Inside our function, let's create a variable named a response. As its value, we'll call the JavaScript fetch method using the await keyword. Let's pass the API URL parameter as the fetch method's argument. We can now return a response.json on line 5. We'll also export the fetchAllProducts variable so that we can use it in other files. On line 8, let's create our product slice variable. As its value, we'll call the createSlice method and supply it an object argument. You can see that the createSlice method was automatically imported on line 1. In our createSlice object argument, we have the first property name, and for name, we have products. Let's give our product slice initial state an object value with properties data as an empty array and fetch status as string. The value of data will be an array of objects representing each product data, and we'll use fetch status to tell our components whether the product data is being fetched, has been fetched successfully, or whether there was an error when fetching the product data. For our product slice reducers, we can create actions for adding new products and updating or removing product data, but we won't need those functionalities in our app. What we need right now is to tell our slice what to do with the fetch data from our fetchAllProducts action. We'll need to update the state with the product data after it's been fetched successfully and update the status with the fetch state property, which can be loading, success, or error. Since we want to work on an already created action type instead of creating a new one, we'll need another key in our createSlice object named extra reducers. The extra reducers option allows createSlice to respond to other action types besides the types it has generated. So, unlike reducers, extra reducers won't generate actions in the product slice.actions property. For our extra reducers value, we'll create a function with a parameter named builder. We'll use the builder notation to add case reducers so that we'll be able to update our state based on the status of our fetchAllProducts action. Let's call builder.addCase to add a new case. The addCase function expects its first argument to be the dependent value and the second function argument to tell our reducer what to do. Since the createAsyncThunk method returns a promise, our fetchAllProducts variable will have the fulfilled, pending, and rejected properties. For our first case, let's use the fetchAllProducts.fulfilled property to know when our data has been fetched successfully. As a second argument, we'll create a function with parameters state and action. Action.payload will contain the response data from our fetchAllProducts action. Let's update our state.data property with the action.payload data. We'll also update state.fetchStatus to success. Next, we'll add the fetchAllProducts.pending case, and we can either do builder.addCase again, or just extend the one we're already using on line 13 with another .addCase property. So we can go ahead and break this down. We'll use our fetchAllProducts.pending case to know when our data is being fetched, so that we can either show a loading text or loader animation in our app. For our function parameter, we only need state. Let's update state.fetchStatus to loading. We'll also add the fetch all products.rejected case. So we have .add case and fetch all products.rejected. Our function parameter will only need state, and I'll update state.fetch status to error. Now, when we dispatch the fetch all products action, our product slice reducer will update the fetch status state to either success, loading, or error. And if the fetch request is successful, it will also supply the data states with our product data. Let's learn how to dispatch the fetch all products action and use our fetched product data. First, we'll export product slice as the default from the product slice.js file. So this is export default product slice. And we'll go over to the store.js file and import the product slice. We'll do that on line 3. Next, we will add product slice.reducer to the store reducer object with a key named products, just like we did for cards. This is product slice.reducer. With this done, we'll be able to access the product state from any component. Let's go to the home component and use our product state. We'll start by importing fetch all products from data/product slice. On line 8, instead of destructuring card product IDs directly from state.cards, let's create a state variable so that we can also get our products from it. We return just state instead of state.cards. On line 9, we'll destructure cards and products from state. And this is equal to state. Let's go to our JSX and update card product IDs to cart.cards product IDs. We'll do that on line 26 and 31. We'll dispatch the fetch all products action in a useEffect hook to prevent it from running more than once. So let's call useEffect on line 14, and you can see that that's automatically imported on line 6. In our useEffect method, we have a function, and inside our function, we'll dispatch the fetch all products action. So let's call dispatch, and then we have fetch all products. The URL for our HTTP server and product list data is http localhost 3000/products. We'll also add dispatch to our useEffect dependency array. So this is dispatch on line 16. Now we can remove our product list import statement and use the product variable from our state in the JSX code. So on line 20, instead of product list.products, we have products.data.map. Over to our browser, we reload our page and see that we're getting all our products from the HTTP server using createAsyncThunk API or other external libraries along with an async function every time we want to fetch data in our components, especially when we want to use the fetch data in multiple places. Sometimes we might need to work with multiple sources of data in our React apps. For example, if we stop our HTTP server and go back to our browser, see that when we reload our app, our product catalog section is blank. We can add a message that tells our user about the server error, but for our app, let's fall back to the product list.json file whenever the HTTP server is unavailable. To do this, we're going to import product list from data/product list.json inside of the product slice.js file. So on line 2, we have imports product list from data/product list.json. And in the builder case for fetch all products.rejected, let's give state.data a value of our imported product list.products array. So this should be product list.products. Or we can now go back to our browser and reload our application, and we have products from the product list.json file displayed to us. This is one use case for working with multiple sources of data but it's only ideal for a demo app and not the real life e-commerce application. But with Redux Toolkit, you have the flexibility of getting data from multiple places and even fetching data in individual components and updating the state with the createAsyncThunk method. So while it's an opinionated tool, you still have the freedom to choose what parts of it you want to use in your React application. As we've seen, Redux Toolkit makes state management straightforward compared to other state management solutions for React and the bare Redux library. We've learned how to set up Redux Toolkit in React applications, what the store is, and what actions and reducers are. We also learned how to get data from our state with the useSelector hook and how to modify our state with the useDispatch hook. Using the createAsyncThunk method, RTK query, eliminating the need to handwrite data fetching and caching logic. Learning RTK query is an excellent next step in your Redux Toolkit journey. I highly recommend checking out the Redux Toolkit docs to explore more about this powerful yet straightforward state management tool. Thank you for watching this course. I hope you enjoyed learning about Redux Toolkit as much as I did teaching it.